human flight possible? How do all those airplanes in the skies above us get there, and what keeps them up there? These are some questions you might have asked yourself. Hi, I'm HOUSSAM EDDINE, and let's take a few minutes to learn just how these interesting machines take flight. First, let's look at some history. Many crazy flying machine designs were tested in the 19th century because of mankind's quest to fly. Finally, one attempt succeeded, and yes, you're right. It was the Wright brothers. Their aircraft was a success thanks to a phenomenon of physics called the airfoil technology. We'll get back to it later. When you study any object that flies, coasts, or floats, all of them are going to have four main forces acting upon them at all times: lift, drag, thrust, and gravity. Thrust is the force that moves the airplane forward. Propellers or jet engines reduce the thrust, just like a smaller engine propels a car forward. Drag, which compensates for thrust, puts the airplane backwards because of the air resistance. Gravity or weight pulls the airplane towards the ground. And not to forget, lift, which compensates for gravity, is what keeps the airplane up in the sky. An airplane flies when all those four forces, lift, drag, thrust, and gravity, work together. On an aircraft, the wings are responsible for generating lift. The larger the aircraft, the bigger the wings, since larger wings produce more lift and support a heavier plane. To demonstrate that, let's perform some experiments. To test this, let's start by making four different paper planes. You may have made a paper airplane at home before, right? Keep in mind that we have to use the same type of paper, so each plane weighs the same. What I'm gonna do now is that I'm going to launch these four paper airplanes 5 different times and record the time that took these planes to get back to the ground. Here's what my test results look like. As we can see, each of these designs have different flight times, and you can see based on this graph, the larger the wing area, the longer the paper plane stays in air. This is because larger wings generate more lift. Airplane wings are shaped to make air move faster on top of the wing. When air moves faster, the pressure of the air decreases. So the pressure on top of the wing is less than the pressure on the bottom of the wing. This difference in pressure creates a force on the wing that lifts the wing up into the air. The wings have a curved shape. This shape pushes the gushing air downwards as shown. Newton's third law of motion comes into picture here. If the wing pushes the air downwards, the air should also push the wing in the opposite direction with an equal magnitude. This eventually results in the lift force, and the aircraft will fly off the ground. Even today, the airplanes make use of the same airfoil technology to fly, but with a highly aerodynamically airfoil shape, and that's what's made the Wright brothers aircraft fly. To sum it up, a lot goes into creating a massive passenger airliner. However, the science behind the airplanes isn't as complicated as you might think. You only have to master 4 basic principles: lift, thrust, drag, and weight, and learn how to conquer gravity to make something that flies. I'm HOUSSAM EDDINE, and that's aerodynamics stated briefly.